Okay, in this video we're going to look at chords and circles. So in the last video we looked at tangents, which is a line that connects and touches a circle at one point only. A chord is a line that goes through a circle. So if we look at a diagram of a chord is a line that goes through a circle, so it has 2 points of intersection here, but the important thing is that a chord is not the diameter, so it does not go through the center of the circle. Couple of key pieces of information, and these kind of questions that we can get on chords, a diagram is going to be extremely helpful. So first of all, the distance from the point of contact, from the point of intersection, to the center is always going to be your radius, and we will have the same on this side here. We'll have the radius. The chord can be split into two congruent right angle triangles. This point here will be the midpoint of the chord, so let's call that A. So A is the midpoint of the chord. C here is the center of our circle. And what's going to be very important is that this perpendicular line here, so this line here is perpendicular to the chord, and it will split this distance here into two equal parts. That information is going to be key in terms of sometimes the different types of questions that we get. We're given various pieces of information. So we're going to look at a question where we are given the midpoint of a chord and we're asked to find the equation of the chord. We're also going to look at a question where we're given the slope of a chord and the length of a chord, and we have to work backwards and find the equation. And making a diagram like this is going to be key. So you have to be able to recognize that a chord will intersect the circle at two places. The chord will be split in half by this point here, point A, which is the midpoint, and this line connecting point A to point C, the center of the circle, will be perpendicular to the chord. So a couple of things that we can know about that. The line from C to A, the slope of this line is going to be perpendicular to the slope of the chord. So that means that M1 multiplied by M2 will give us -1. And if we have one slope, we can flip and change the sign to find the other. The fact that we have a right angle triangle here means that we can use the Pythagoras theorem. So if we have the point A, the point C, and we'll say we have the radius here and we have the distance x from C to A, we can also use that information to find the length of the chord. All right, so it is important to be able to draw a quick sketch of a diagram, fill in as much information as possible, and then use that to solve your question. So the first question we're going to look at is on page 331. It's exercise 12, and it's question 5, part A. So exercise 12 on page 331. And question 5A is the question we're going to look at first of all. So the first thing we're being asked here is to find the equation of the chord of the circle. So we are given the equation of the circle, which is x squared plus y squared equals 81. And we are also told that the midpoint of the chord is the point 2 minus 3. So we want to find the equation of the chord and the length of the chord. So we're asked to find two things. Number one, the equation of the chord, and two, the length. Now with this question, I would always draw a quick sketch of a diagram, and that can get us started in terms of how to start answering the question. Now, again, when we are given the equation of a circle, the first two things you should be looking to find are the center of the circle and the radius. Now, given that we are looking at the most basic format of the equation of this circle here, the center point of this circle is going to be 0, 0, and the radius is the square root of 81, which is 9. So now that we have those pieces of information, let's draw a quick sketch. So on our axis, we know that 0, 0 is our center point of our circle, and we have a circle of radius 9. All right. We have a point 2 minus 3, which is the midpoint of our chord. So let's call that point A for the moment. And because this is the midpoint of our chord, and we know that joining the center of the circle to this midpoint will form a perpendicular line to our chord, that there is what our chord is going to look like. So a couple of extra bits of information that I can fill into my diagram here. The radius of my circle is 9. And I can fill in the coordinates of my points at 2, -3, and 0, 0. Okay, so let's look at trying to solve the question. So remember, in order to get the equation of a line, we need two things. We need a point on the line, which we have, and we also need the slope of this line. To get the slope of this line, the first thing we will have to do is find the slope between the center and the midpoint. If we find the slope here, we can find the perpendicular slope by inverting and changing the sign, and then we have a slope of our chord. So first of all, the slope from point C to point A, the formula is y2 minus y1 over x2 minus x1. So filling the information into my slope formula here, y2 minus y1 is -3 minus 0 over x2 minus x1, 2 minus 0. So my slope of my line from the center to the midpoint of the chord is -3 over 2. Now remember, because m1 multiplied by m2, because they're perpendicular, they'll multiply to give -1. What we do is we flip the fraction upside down, change the sign, so the slope of the chord, turn it upside down, change the sign, is 2/3. All right, then coming to the equation of the chord, we fill it into the formula y minus y1 equals m by x minus x1. So we have a point on the chord, which is 2 minus 3. And we have the slope of the chord, which is 2/3. So filling the information into the formula, we have y minus -3 is +3 equals 2/3 by x minus 2. And tidying up a little bit, we're going to multiply everything by 3 first of all. 3y plus 9 equals 2x minus 4. And bringing everything to one side, 2x minus 3y, bring the 9 across, minus 13 is equal to 0. So that there is the equation of our chord. The other thing we're being asked to do is find the length of the chord. So again, a quick diagram is going to be useful here. So looking at the information that we have, right, we have our midpoint, A, our center point, C. We know that the radius of the circle is 9. So in order to find the length of our chord, which is double the distance from point A to this corner of let's call this B here. So double the distance from A to B, because the distance AB represents half of our chord. First thing we need to do is get the distance between A and C. We use the distance formula for that. So the distance from A to C is the square root, if we're looking at point A, which is 0.2 minus 3, and point C, which is 0, 0. 2 minus 0 to be squared plus -3 minus 0 to be squared, which gives us a distance of root 13. So filling that into my triangle here, I can now use the Pythagoras theorem to find my missing length of my triangle. So AB is the square root of 9 squared minus root 13 to be squared, which gives us a distance of 2 root 17. Because this is half of the distance of the length of the chord length is double this here, which gives us a length of 4 root 17 units. We say units because we aren't given any any quantity like centimeters or meters or anything like that. So that's how we find the equation of the chord and the length of the chord when we are given the midpoint. The next question we're going to look at is question 5C, and we're given again slightly different information, but we're asked to do the same thing. So in question 5C,